In this video, we solve this problem in which we're given a differential equation and asked to verify that a given function is a solution of that differential equation. I believe this is problem 1A on written homework number 1 in the spring 2021 semester. So we have this function and we want to verify that it's a solution to the differential equation. That just means that if I take the derivative of this twice and I substitute it into the differential equation, the left-hand side will equal the right-hand side on some interval. And I believe this will work for all real numbers. So the way that we would start is we'd look at the left-hand side, well, look at both sides of the equation and see that we've got a first and second derivative here. So then since we have a first and second derivative, we should compute the first and second derivative of this function so that we can plug it in and then show that the left-hand side simplifies to the expression on the right. So let's just start by computing that first and second derivative. So if y is a function of t, and we're taking the derivative with respect to t of 2t minus 1 times this exponential function, minus 4 times this exponential function. This is a product. I've got a first function here and a second function here. The derivative of a product is the derivative of the first function times the second. Derivative of a constant times t is just that constant. Derivative of -1 is 0. So the derivative of the first is 2. Then we multiply by the second function, undifferentiated. And then we add the derivative of the second function times the first. Now the first function is 2t minus 1. Derivative of e to some power is e to that power times the derivative of the inside by the chain rule. Now the -3t over 2 can be rewritten as -3 over 2 times t to the first. And if you're not sure, just watch. If you multiply straight across here, you get that. And this t to the first over 1 is the same as just a t to the first, or just a t. So this is the same as this. So when I say the derivative of e to some power is e to that power times the derivative of the inside is the derivative of this constant times t. So we'll just get the constant. And that is, of course, multiplying this exponential in that polynomial function. So this is the product rule, derivative of the first times second plus derivative of the second times the first. And then over here, we just bring the 4 down. And then we say, what's the derivative of e to some power? The derivative of e to some power is e to that power times the derivative of the inside, which happens to be a 2 in this case. Derivative of a constant times t is just the constant. So we'll simplify. From here, this -3 over 2 times 2t will give me a -3t, and then -3 over 2 times -1 is +3 over 2. And then this and this both have an exponential function, this e to the -3t over 2 as factors, so we can factor that out. And then you have -3t plus 3 over 2 plus 2, so that's 3 over 2 plus 4 over 2, which is 7 over 2. And that's what we have there. Oops, that's not y, that's the derivative of y. Okay, and now we're ready to take the derivative again. And we're taking the second derivative because the differential equation was second order. You don't have to show this step if you don't want to. So I've got a product again, so I'm going to use the product rule again. We have the derivative of the first times the second. Derivative of e to some power is e to that power times the derivative of the inside. The derivative of the inside is the constant that's multiplying t, and the constant that's multiplying t here is that -3 over 2. that's derivative of the first times the second. And then we want to add the derivative of the second function, which is -3, times the first. Bring the -8 down. Derivative of e to some power is e to that power, times the derivative of the inside. Derivative of 2t is 2. And then here you can distribute if you'd like. We have this -3/2 times -3/1 times t. So it's going to give me a positive 9/2 times t minus -3/2 times 7/2. Multiply straight across, it's going to be -21/2. And then we're subtracting 3, which is the same as subtracting 6/2. And that's all multiplied by that exponential. I'm just factoring that out from these two terms. And then, of course, 8 times 2 is 16. Oops, I inverted that by mistake. That should be a 9/2, not a 2/9. Okay, so we have, this is our second derivative and that is our first derivative. Let's substitute into the differential equation, substitute into the left-hand side and see if we can't simplify that to make it look like the right-hand side. If we've done everything correctly, it should work out. The left-hand side is 2 times y double prime, which is this. And actually, it might be helpful to distribute these exponentials now. So I've got 9/2 times t times that exponential, minus 27/2 times the exponential, minus 16 times e to the 2t. That's 2 times y double prime. And then we're going to subtract y prime. I will distribute there as well. When I just subtract this, that's just going to change each of these signs. So subtracting -3t times that exponential is going to be adding 3t times that exponential. Then I'm subtracting that, so I have minus 7/2 times the exponential. And then I'm subtracting this -8, so that means I'm adding 8. So I've distributed the negative to this and distributed the exponential, and I'm writing that here. And then the last term says minus 6y. That's what it says there. So I just need to subtract 6 times y, where y is this. And I think I will just write y in, but I'll distribute that exponential. So we have 2t times e to the -3t/2 minus e to the -3t/2. And then we have a minus 4 e to the 2t. So that's our left-hand side. It's this plus this minus this. It would be easier to simplify if we distribute that 2 and that -6. So I think I will. And I'm going to keep everything sort of lined up like this as I do, because I've got my t's times this exponential here, my constants times this exponential here, and the constants times e to the 2t there. It's going to make it really easy to do the bookkeeping so I can keep track of what cancels and what doesn't. So 2 times this is just going to give me a 9t times that exponential. 2 times that is -27 times the exponential. 2 times -16 is -32. And then here there's nothing to distribute, it's just a 1. So I'll just write this down. And then here I want to distribute the -6. This is going to give me a -12t times that exponential. -6 times -1 is +6 times this exponential. And then we have a -6 times a -4 is +24. Oops, and actually I see a mistake that I made from earlier. when I took this negative 3 over 2 and I multiplied it by the negative or the positive 7 over 2, I should have gotten negative 21 over 4. And then to get a common denominator here, I need that to be a 12 over 4 to give me the negative 3. So negative 21 minus 12 is minus 33, and that should be over 4. Sorry about that. This should be 33 over 4. Which means that when I multiply that by 2, I should not have this 27 here. I should have a negative 33 over 2 there. Okay. Okay, now let's see if there's any cancellations. Hopefully there are a lot of them. We've got 9 of these, 3 of these, and minus 12 of those. Those all reduce. Great. And 8 of these plus 24 of those. That's 32 of those. And then we're subtracting 32 of those. Also great. And then here we have negative 33 over 2 times this exponential minus 7 over 2 times that exponential. So that's going to be negative 40 over 2. So that's negative 20 times the exponential. Negative 20 plus 6 is 14, or negative 14, excuse me, times the exponential. And let's check it out. Is that the right-hand side? It is. So after some simplification, once I corrected my arithmetic error, which I fortunately caught, we showed that the left-hand side does simplify to the right-hand side. So that means that y equals 2t minus 1 times e to the negative 3t over 2 minus 4e to the 2t is a solution of the second order differential equation.